Hi everyone! In this video, I'm going to show you how to use the sine, cosine, and tangent ratios, which are the sin, cos, and tan buttons on your calculator, to solve for angles in a triangle. So I'm sure you've seen these buttons on your calculator before, that sin button, cos button, and tan button. And it turns out that through a couple steps, you can actually use those buttons on your calculator to figure out exactly how steep a line is. Like what angle you have in a triangle, or what angle you have in some sort of slope, like how steep is your roof? Well, you can figure that out pretty easily using the sine, cosine, or tangent ratios. So it's actually kind of useful, actually it's very useful, particularly for anyone going into trades or anyone who's doing design or like computer design, anything like that. Angles come up a lot. And in fact, the tangent ratio in particular is used in computer graphics literally billions of times per second to come up with those fancy graphics you see on the screen. It's really incredible how powerful these trig ratios are. So here we go. Sine, cosine, and tangent are defined as a ratio. A ratio is just like a fraction between two sides. So sine of theta, cos of theta, and tangent of theta is how we write these things. And let's go through what each of these things means in turn. So sine, S-I-N, is short for sine. The whole word, if you were to write it out, is actually S-I-N-E. So even though it's spelled sin, it's pronounced sine, if that makes sense. So that's sine. And then theta, that fancy letter there, that's actually a Greek letter theta. It looks kind of like a cursive O, and it's always an angle. And sine of the angle theta that you have is a fraction of the opposite side divided by the hypotenuse. Okay, so to understand what that is, we actually need to know what is our opposite side and our hypotenuse. So let's look at this red triangle down here. So first of all, since this is the right angle here, the side that's across from the right angle is called the hypotenuse. Okay, and hypotenuses only exist in right angle triangles, and the hypotenuse is always the longest side in a triangle, and the hypotenuse is across from the right angle. Okay, so in this triangle over here, this side over here is also the hypotenuse because it is across from the right angle. Okay, so these two are our hypotenuses. Now, this is the part that some students find confusing with sine, cosine, and tangent. There are two angles other than the right angle, right? So you could pick theta to be this angle down here, or you could pick theta to be this angle up here. And the reason this makes it confusing is depending on which angle you're trying to find, that changes what your opposite side and the other side that we haven't talked about yet is your adjacent side are. So the opposite side is across from, it's opposite the angle theta that you chose. So in this triangle here, we chose theta to be that angle down here. So across from theta is the opposite. If we choose theta to be the other angle in this triangle, if theta is up here, then the opposite side from theta is down here. Okay, so that's the hypotenuse, that's the opposite. If you look across at cosine, you'll see there's another ADJ. ADJ is short for adjacent. And so adjacent is the side that's just like right next to theta. Adjacent is just another, well, actually beside is a synonym. It means the same thing as adjacent. So adjacent is beside the angle. Okay, so the sine of an angle is equal to the opposite side divided by the hypotenuse. The cosine of your angle, theta, is defined as the adjacent divided by the hypotenuse. And the tangent of your angle is defined as the opposite divided by the adjacent. And even if we were in class and we were doing this in regular school, you would always have those three formulas available to you. But there's sort of a memory trick that a lot of students learn because we use sine, cosine, tangent fairly frequently, and we want to be able to do it fairly quickly. There's this SOH CAH TOA piece that helps you figure out which one's which. Now, I like to pronounce the H because this H here represents the hypotenuse. So I say SOH CAH TOA, right? So you need to get rid of sort of guttural and feel like you're like a warrior and you're like so, right? A battle cry, or at least that's how I imagine it. Anyway, pronouncing the H helps. And what this means is so literally means that sine of your angle, right? S stands for sine, and sine always has an angle next to it. So sine of your angle is your O over your H. So that is your opposite over your hypotenuse, right? So that's why we say so. And ka is cosine of your angle. Cosine of your angle is your adjacent over your hypotenuse. And then toa is O over A. So the tangent is O over A, which is your opposite over your adjacent. Okay, let's actually get into a problem. So we are going to, in this video, we're going to do solving for angles. So we're going to find this angle here. Now, in order to find that angle, we actually need to know how to do what are called our inverse operations on our calculator. So there's two things that we need to do in our calculator before we can even get into this. First thing is we need to make sure that we're in degree mode. So you need to be in DEG mode. And on some calculators, there's a button that looks like this, D/G/R. Or if you've got a fancy calculator like this, you go into the mode button. And as you can see, I've got degrees selected. So on a basic scientific calculator, it will say DEG, usually like near the top of the display. Like up here, it would say DEG. In fact, this one actually says degree right there. So make sure that you are in degree mode, because otherwise you're going to get something called G, which is gradients, or R, which is radians. And we're not even going to talk about those. They aren't really relevant to this course. You want it in degree mode. So hit your GR button if you have one, or sometimes you need to go into the mode or settings to change it into degrees. Or usually if you reset a calculator, most calculators, not graphing calculators, but most basic scientific calculators actually default to degrees. So if you hit that reset button on the back of your calculator, it will probably put you into degree mode. And one way you can quickly check if you're in degree mode is you can do tangent of, what am I doing? Tangent of an angle. So let's do tangent of 45. So if you do tangent of 45, you should get 1. Okay? If you put tan, or in some calculators, if you've got like a backwards calculator, you hit 45 and then the tan button, and sometimes you need to hit equal, you should get 1. Or if you've got like a fancy scientific calculator, it'll open brackets for you, and you put in 45 and hit equals, you should get 1. And if you get 1 from tangent to 45, you're in the correct degree mode. So let's actually check to make sure that we can actually do this correctly in our calculator. Let's try all of these. And I'd actually like you to pause the video with your calculator and make sure you're getting the right answers for these, because if your calculator is in the wrong mode and you can't figure it out, then you're going to get the wrong answer for every single question. So sine inverse is the other thing we need to do to be able to find an angle. And if you look above sine, cos, and tan in your calculator, you'll see sine -1, cos -1, and tan -1. And for various reasons we aren't really going to get into, that -1 symbol means inverse. And so inverse operations are like undoing something. It's the opposite operation. So what we're doing is the opposite of sining, which is sine inversing. And the way you do that is second function sine. And you'll see now there's a -1 in my sine. And if I do second sine of 0.515150, that gives us 30.99 degrees. So rounding to the nearest degree, the 9 rounds up to 31. Let's do cos inverse of 0.0698. So pause, make sure you can do this, and then come back in a sec. Okay, so if you did that correctly, you should have done second cos and put in 0.0698, and it gives us 85.99, which rounds to 86 degrees. All right, so now that brings us to this next example here. Sine of theta equals 6/10. So let's just do a quick review. If you have something like x squared equals 9, right? Or actually, let's make it c, because usually we see this with Pythagorean theorem, right? So in Pythagorean theorem, if you end up with c squared equals 9, what's your last step? Your last step is to square root both sides, because square rooting is the inverse of squaring. So if you have sine of theta equals 6/10, what you need to do is you need to do sine inverse to both sides, because sine inverse is the opposite of sining something. So just like we square rooted here, because square rooting is the opposite of squaring, and so we square root both sides, here you need to sine inverse both sides, which gives us theta equals sine inverse of 6/10. And normally we wouldn't actually write this out. We would normally just jump right to putting this into our calculator. But the first couple times I'll show you guys. Sine inverse of 6 divided by 10. And on our calculator, you just do second sine of 6 divided by 10. Now that's if you've got like what I'd call a forwards calculator. By now you've probably figured out if you've got a forwards calculator or a backwards calculator. So on a forwards calculator, you see this is 36.86. So this is 37 degrees if we round to the nearest degree. Now, if you've got like a backwards calculator, the way you do this is you do 6 divided by 10 equals, and then you do second sine. And some calculators you need to hit equals here, usually you don't. And that should also give you your 37 degrees. Okay, so pause right now, check that you can actually get 37 degrees, or 36.869 on your calculator. Okay, cool. So we're back. Hopefully you're able to do this. If you still can't figure it out, please contact me and I'm happy to help. So then let's go through, oh, here we go. This is what I was showing you about the inverse operation, right? So if you've got sine of theta equals this stuff, we're trying to solve for theta. So you need to do the opposite of sine. And the opposite is sine inverse, which is why you put sine inverse on the right-hand side. Okay, why don't you try these three on your calculator? Pause, and then I'll put the answers up. Okay, answer time. Second tangent of 0.9657 is 44 degrees if you round to the nearest degree. Second cos of 0.9998 should be 1 degree, right? Because that's almost flat. And then, so this one, what we're going to have to do is we're going to have to actually cos inverse our right-hand side. So hopefully you figured that out, because the opposite of sine is sine inverse. The inverse of cos is cos inverse. So we do second cos, 8 divided by 10, and we get 37 degrees. All right, so that is how you use the button in your calculator. Okay, we're ready for this? Now let's actually figure out how to label and set up our sides. So this is our first real problem. Let me erase this so I've got some room. Okay. Now here's the process for finding an angle. First thing you should always do is label your sides, starting with the hypotenuse. So across from the right angle is the hypotenuse. So I'm going to put an H there for hypotenuse. Once the hypotenuse is labeled, then I'm going to find the angle that we care about. In this case, it's this phi symbol, whatever, over here. Now, since that's the angle we're trying to find, see it says find the labeled angle. So across from our labeled angle is the opposite. So we're going to put O. And then the last thing you should label is the thing that's right next to your labeled angle, which is the adjacent. Now we are trying to find this angle here. And we need to decide which two sides we're going to use. So we've got three choices. Where are the formulas? Here, there. So you either will know the opposite and the hypotenuse. If you know the opposite and the hypotenuse, you're going to use the sine. Or we might know the adjacent and the hypotenuse, in which case we'll use cosine. Or we might know the opposite, and the adjacent, in which case we're going to use tangent. And in all three cases, you'll notice that there's two sides that we know. So let's look at this problem here. Which two sides do we know? I have the value of the opposite side. The opposite side is 12.4 centimeters. And I know the value of the adjacent side is 16.5 centimeters. The hypotenuse, I don't know. It's just labeled A. So because I don't know the hypotenuse, I'm not going to use the hypotenuse. I'm going to use O and A. So now I need to decide, do I want, let's do it like this. So S, C, T. So sine is so. Ka is adjacent and hypotenuse. Or TOA is opposite and adjacent. Now I've color-coded it. Hopefully that makes it a bit clearer to see. Which two sides do we know? We know the orange side, opposite, and we know the green side, adjacent. So we are going to use TOA to solve this. So we are going to write, can we erase this degree mode thing? We got some room. So we are going to write tangent of our angle, theta, equals opposite over adjacent. So all that I've done there is I've rewritten this formula that you get. Tan theta equals opposite over adjacent. I've just rewritten that. So now what I'm going to do is I'm going to substitute my values. So tangent of phi, I guess in this case, equals my opposite, 12.4 centimeters, I guess, but it doesn't really matter. 12.4 over my adjacent, 16.5. And I'm trying to solve for this variable phi. So phi then is tan inverse of my opposite over my adjacent. So I'm going to do second tangent of 12.4 divided by 16.5. And that gets us 36.9, 37 degrees if you round. So phi is 37 degrees. Okay, that's how you solve for an angle. Okay, let's try this one here. We're going to solve for angles A and angles B. Now the cool thing is, in this triangle, I've got all three sides available to me. I've got my 9, I've got my 12, and I've got my 15. So I know all three sides, so I get to choose. It also says we need to solve for angle A and B. So I get to choose which angle I want to solve for. I'm going to choose this angle here. We'll call that B, I guess. It doesn't really matter. You could also choose to solve for A up here instead. But that's going to change how you label your triangle. So it's very important that you label your sides in the correct order. Across from the right angle is the hypotenuse. Across from the angle we're trying to solve for is the opposite. And the remaining side is the adjacent. Now in this triangle, I can use whichever ratio I want because I have all the sides, right? I know my opposite, I know my adjacent, and I know my hypotenuse. So I guess I'll do sine because sine is the first one. So I'm going to do opposite over hypotenuse. But since we know all three, you could have done cosine or tangent because you actually also know the adjacent. So I'm going to choose to do sine. So I'm going to set up sine of my angle equals a fraction, right? So sine always has to have an angle next to it. It always then equals a fraction. So that's how I'm always going to set it up. Sine of the angle equals a fraction, and my fraction in this case is my opposite, 12, divided by my hypotenuse of 15. And now I know that B then is going to be the inverse sine of that right-hand side stuff. So inverse sine, second sine, of 12 divided by 15 is 53 degrees, if I round correctly, right? Cut off the 1. So B is 53 degrees. And now this last angle here, we can find directly now. The angles in a triangle add up to 180 degrees. So we've got 180 degrees total in the triangle. We use up 90 degrees for our 90-degree corner. We've used up 53 degrees for B. Whatever's left has to be angle A. So A equals 180 minus 90 minus 53. Subtract, and we get A is 37 degrees. So A equals 37 degrees. And if we want to be fancy, we could throw the angle symbol in front of these, but whatever. Okay, so that's how you find the angles in a triangle. Oops. So there's practice on the next page. Now I only want you to solve angles this week. So name the sides. Yes, we should do this one. Name the sides, so label opposite, or label hypotenuse, then opposite, then adjacent. Depth is length, 3 is length, 4 is length. Solve all the information we'll do next week. So question 6 is solving for angles. What is the angle of the sun? What is the angle of elevation? Angle of elevation, by the way, is just the angle up. So this angle here is the angle of elevation. This tells you that the angle can't be greater than 75 degrees, so you need to find that angle and compare it to 75. What is the angle it needs to spray? Does it fall in this range of degrees? Okay, so question 1 on the first page, and then 6 through 11 on the next page.